Okay, let's start today. Cantilever subjected to varying load. You can see these is a cantilever fixed at one end and free at other end. Now for this it is a load W per unit length. This W load is acting to the full length of the beam, to the full length of the cantilever. First we have to determine the load at this section. I have made a section for determining shear force and bending moment. First I have to determine load at this section. So how will determine load at this section? See, very easy way I am showing it. For L length, load is how much? W. For 1 unit length, load will be how much? W by L. For X unit length, what will be load? WL by into X. So W into X by L. See, I have written here W into X by L. Now shear force. Shear force means half. What will be half shear force? F. F will be equal to half into, you have to determine area for it, half into base. What is base here? X. And what is height here? That means what is the value of load at section XX? This is W into X by L. So put here W into X by L. Now this is section XX. Leftward downward. Left downward it is what? It is negative. So I'll put here negative. So it is how much shear force? It is Wx square divided by 2L. So it is square, that means it is parabolic variation. Okay, before determining parabolic variation, let me say I have made earlier a mistake. This is not cubic variation, this will be also parabolic variation. Okay, that earlier maths which I have explained you in simply supported beam subjected to UDL, by mistake I have said it is a cubic variation. It is not cubic variation, it will be parabolic variation. So shear force is how much? Minus Wx square by 2L. So minus Wx square by 2L. Now I will determine shear force at x equal to 0 and at x equal to L. At x equal to 0, what will be the force here? 0. If you put the x value here, it will be 0. And at x equal to L, what will be the shear force here? Put here x equal to L. So you will get W into L square divided by 2L. So it is how much? It is WL divided by 2. So it will be minus, it will be minus. So at x equal to 0, shear force is 0, and at x equal to L, shear force is minus WL by 2. Let's plot it. At x equal to 0, shear force is how much? 0. At x equal to L, shear force is how much? Minus WL by 2. Let minus WL by 2, it will go downward. So up to that much, WL by 2. And this is 0. Now I have to find at any midpoint shear force. Let's determine shear force. So it is the shear force diagram. We do not have to determine the shear force at any midpoint because we have known the value of shear force at 0 and shear force at L point. Now let's find bending moment. For bending moment, simply moment means what? It's force into distance. So what will be the force here? For determining force in varying load, we have to find the area. That means it is a triangle. So we'll find the area half into base into height. So this half, base will be how much? Will determine moment up to the section X from the free end. So half into base into height. Height means what is the load intensity at this section XX? This is W into X by L. So W into X by L. And now it will be CG. So load into distance. So distance will be what? CG. CG will be how much? It is from this end, CG will be X by 3. So this is how much? X by 3. So what is the value of this? This is W X cube divided by 6L. Now what will be sign convention? Sign convention, due to this loading, the cantilever will try to bend downward. That means it will be hogging bending. So hogging bending, the sign will be negative. And variation, since the expression here is cube, that means it is a cubic variation. Okay, now let's find moment at x equal to 0 and moment at x equal to L. If you put the value, you will get moment at x equal to 0, it will be 0, and moment at x equal to L, this will be what? WL cube divided by 6L, that is minus, so cut it, there will be L square. So WL square divided by 6 minus WL square by 6. So this is the moment here at x equal to L. See, at 0 the moment was 0, and at L the moment will be WL square by 6. Let the value of WL square by 6 be that much. I will go downward because it is negative. Then we will connect this by cubic curve because it is a cubic variation. So this is the bending moment and it will be negative, and this is the shear force, it will be also negative. So friends, this is the shear force diagram and this is the bending moment diagram for a cantilever subjected to varying load.